Hey guys, this looks like a fun one. We're given 8 to the 3 to the I to the 2 to the 4 to the 0, and it wants us to simplify. If you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. This is a power tower, and you evaluate these by going from the top down. So we're going to do the 4 to the 0 power first. Anything to the 0 power is equal to 1. And typically this is how it's explained. You have something like 3 cubed, then 3 squared, then 3 to the 1, then 3 to the 0, 3 to the negative 1, 3 to the negative 2, and so on. 3 cubed is equal to 27, 3 squared is 9, 3 to the 1 is 3. And you'll notice for each row, we divide by 3 each time. So to get 3 to the 0, we're going to divide by 3. 3 divided by 3 will give us 1. And that's a quick demonstration why 3 to the 0 is equal to 1. And if you want to learn about negative exponents, we can go even further. 1 divided by 3 is 1/3. So 3 to the negative 1 is 1/3. We can divide by 3 again and we get 1/9. So 3 to the negative 2 is 1/9. So this isn't exactly a proof, but it's a pretty cool demonstration. And we could change the 4 to the 0 into a 1. Next, we're going to focus on this 2 to the 1. Well, 2 to the 1 is equal to 2. I don't think we need to talk about that. Next, we have I squared. For the most part, people use two different definitions for I. They say either I is equal to the square root of -1 or that I squared is equal to -1. There's some people who don't like this definition, and there's interesting reasons why. You should be fine using this as a definition for I. If we focus on this blue one, copy it down, and then square both sides, the square root and the square are inverse operations, so they're going to cancel each other out. And we're left with I squared is equal to -1. Regardless of which definition you use, they both tell us that I squared is equal to -1. So we can change this I squared to -1. Next, we're going to do the 3 to the -1. And earlier we demonstrated that 3 to the -1 is equal to 1/3. So we can change this to 1/3. And now we have a fraction as an exponent. These are called rational exponents. Here's the notes for rational exponents. The denominator is the root and the numerator is the exponent. So this 8 to the 1/3 can be rewritten as the cube root of 8. This denominator tells us the index of the root. And if you want to see a demonstration for these notes, we can do that as well. We go back to our 8 to the 1/3 power and set it equal to x. I don't really like fractions, so to get rid of this fraction, we can cube both sides of the equation. This 1/3 is going to multiply by the 3, which gives us 1. And then 8 to the first power is 8. Now we have 8 is equal to x cubed. From here, we can cube root both sides. And on the right-hand side, this cube root and the cube will cancel each other out. So we end up with x is equal to the cube root of 8. And that's the same thing we had from the notes. And from here, the cube root of 8 is equal to 2. This is the answer to our question. Let's put a box around it. How exciting.